All right, year 11, Tech 2 on 14b, which is the tangent function. So as you can see on here, you have the unit circle. Across you have your cos and your verticals, your sine. Your tangent is defined as the ratio of the two. You find out later on as we use similar triangles on that parallel line to the y-axis. That is your tangent value from the intersection of the radius to that vertical line, and they will be linked to a new identity with a reciprocal function that we'll see in the next exercise. That is now the tangent function, as y is the tangent and x is your angle. Along the x-axis, your angle will be labeled in radians. Looking at the main function, it's a periodic function, so it keeps repeating to infinity. We'll see along in the next slide the summary of the features. First is the way it repeats is what we define as the period. The period is pi. You also have a as the y values are going from negative infinity to positive infinity, that is your range. With your domain, it's going to be r excluded your asymptote, and those asymptotes have the equation x equals pi on 2 plus a multiple of pi, and that can be summarized as a condensed formula. What else do you need to know? The axis intercept, the x-intercept, so it's 0, pi, 2 pi. So that is defined as k pi, and k is the integer parameter. So here is the summary of what I just mentioned. So have a you can pause that and have a read through. I already comment that on the previous slide. Linking to 14a with the symmetry in the unit circle, you will have these properties for this one: second quadrant, third quadrant, the fourth quadrant, which is similar to the negative angle identity, and the last two are coming from the complementary, is when two angles add up to 90 degrees or pi on 2. Here you have an equation that you will need to solve. You will need to know your exact values. First thing that is important to do, as you notice the domain for x, the domain is restricted. It means the number of solution A will be restrained as well. The first thing you need to do is determine the period of that function. The formula for that period is it's pi over n, and n is the coefficient in front of x. So pi over 2 is going to be the period. You notice there's 4 periods over that interval, so that equation should give you 4 solutions. You make your tangent the subject, which is what we have. We have tangent of 2x is root 3 on 3, or 1 over root 3. Find the equivalent exact value, which is tangent of pi on 6. And then we make 2x equal pi on 6, which is the one in the first quadrant. This one is pi plus that angle, so that's your theta. That's your third quadrant, and the others are due to the periodic function, so we can add a period, which is pi for 2x. Okay, now when you make x the subject, now the period is going to be pi over 2. So you can see from pi 12 over 12 to 13 pi over 12, we actually add pi over 2. Previously we add pi because pi is for tangent, that is the period. For that tangent to x, when x is a subject, the period is now pi on 2. So we have 4 solutions here, and those solutions need to be within this interval. Another equation, again, determine the period. The period is pi over a half, which is 2 pi. You have therefore 2 periods over this interval. You should have 2 solutions. Tangent is already a subject. What is equal to negative 1 is to be 1 is tangent of pi on 4, and due to the symmetry from the first to the third quadrant, it's negative pi on 4. Then we add pi to get the solution in the third quadrant, and we might rearrange the formulas to make x the subject respectively, and we get those two solutions. Again, verify that those solutions are within this interval. Alright, last bit is looking at the tangent as a function, so we need to graph it. To graph it is first, again, it's the same principle as your equation. Determine the period, find your equations of the asymptote, so the vertical asymptote, and find the x-intercepts, and then you can do a sketching of the function over one period and then duplicate it over the intervals on the right and on the left. Okay, so here you will have y equals 3 tangent of 2x, the period is pi on 2, the asymptote is here 2k plus 1 over 2 divided by 2, that gives you your asymptote. So you place your vertical asymptotes, which is pi on 4 at an interval of pi on 2, which is the period. Okay, and here because the period is pi on 2, you have 0, pi on 2, and so on. You have your x-intercepts here. So let's start with 0. You have your x-intercept here. You have your two asymptotes on the left and the right. You draw one period, and then you can repeat it on the right and on the left. Okay, and this one is very similar. First, determine the period. Notice a little bit of a difference here. You have a negative coefficient. Due to the negative coefficient, it's you'll see you will have a symmetry from the x-axis. So here, for the previous example, it's an ascending function from the asymptote on the left to the right asymptote. If you had a negative over here, there will be a reflection from the x-axis, and it will be in that pattern, which is decreasing as the coefficient in front is negative. Okay, so you have the period, that's pi on 3. The asymptote is pi on 6, which is this one, and you add pi on 3 every time. The asymptote is again, the x-intercept, the main one, which is also your y-intercept, is the origin. So at 0, you add pi on 3, or you minus pi on 3, which is the period, and you get all your x-intercepts. Alright, and that's it for 14b. See you later.